G'day. So I'm going to have another go at an AI project. I'm going to use Langchain and a visual model to look at my photos. So when I take photos with my iPhone or iPad, it's annoying that they always come down with just like a file number and no really meaningful text about what's on the photo. So I think with AI I should be able to go out, get it to look at each photo, create like a caption or a small file name that's a lot more meaningful. I'll make it easier to download them or upload them. I actually store all my photos on a local Synology device. So there's some other things I want to do with the photos too. So for example, the heic files that come off a iPhone, the Photos app in Synology doesn't really work with them that well, so I'd like to convert them all to JPEGs and do some other things with the files before they hit the storage device as well. So let's have a look at how I'm going to do that. So let me plug in my iPad. So it gave me PC access to my iPad. It now appears on my file menu here. If I look at internal storage, and basically I have all these folders with photos in them. So let me grab all those, and I'm going to put them in this temp directory under image in folder. So let's paste them in there. So after I've copied the photos down from my iPad, in this case, I have a directory ready for each month worth of photos. Sometimes you get more directories than that. So this is the sort of things it contains. So it contains the photos in heic, and also has these move files. A lot of times the photos I take on an iPad or iPhone, they'll have the equivalent move file. So like this image 404 here also has a move file with the same name, and that's kind of the animated version of the still image. So some of the things I want to do when I upload these to my Synology Photos application, I really don't want heic format ones, I want JPEG format ones, so I'm going to do a conversion on that. These move files, I don't really want movies of the still images, so I just don't want to bring those over. And the other thing I want to do is the names of these is you don't really learn much from the names, so this is where I want to use AI to look at the actual images and put together a better file name that has information about what it's seen in the images. So that's where we're going with this. Some of the other files types that I might bring over is there may be JPEGs in this sort of case, and I also want to bring that over and look at it as an image and try and give it a better file title than the title it's got at the moment. So the other thing I want to make sure of is I maintain image metadata when I make copies and update these files. So if we look at properties for this heic file and looking at details, so some of the metadata that you get with it is information about the iPhone or iPad settings when the photo was taken, location, so longitude and latitude, if that was captured, and things like the date that the photo was actually taken. And this is all used in my Synology as well in the Photos application to classify photos and where they are. So I want to make sure that metadata comes along with any copies or conversions of these files I make. Okay, let's see how I designed my Python program. So it's a command line program that's going to take a folder of images and convert them into something I can upload and store and have the new captions that are more meaningful. So first I get arguments that are passed to the command line Python program. That's going to contain for sure a source directory and a destination directory. Source directory is all the images that came off my iPhone, iPad, and destination directory is where the renamed files will go. Optionally, I can also pass a LLM name, so I can use a different model for processing the images, and an Ollama base URL, so I can point it at any Ollama host I want, but there are some defaults in there already for what I'm doing. I set up the Ollama chat model based on the model. Then I start processing the files in the source directory. First thing I do is run through and just get a total file count, and I use that to keep track of where I'm up to as the program progresses. And then for each folder in the source directory, first thing I do is get a list of heic files in that folder. I just build a list that I keep temporarily, and I use that later on for processing move files. And then for each file in that folder that I'm working on at the moment, it'll do go down one of these paths. So if it's a heic file, I don't want to use those up on when I store the images. I want to store them as just common old JPEG files. It's easier to work with. So what I do is copy the heic file as a JPEG version, make sure that I keep any metadata associated with that file, and copy that to the output directory. Next thing I do is these two processes here. So I'll use AI, so I'll be using Langchain again, passing out the image and get a list of 4 keywords, and I'll be using that to build a file name, and then I'll rename the output file based on that new name. I do a similar thing for all the standard image files, other types of image files, but in this case I just have to copy it to the output, get the 4 keywords, and then rename the file. This is where I do something tricky with the move files. So when I take a snapshot with a iPhone or iPad, what it does is takes a little movie as well. I don't want to store those. I don't really use them. So what I do is if I find that there's a move file with the same base name as a heic file, then I don't bother copying it. Other move files I will copy to the output. And then finally I also copy MP4 files. These are the main libraries that I'm using for my program. So from Langchain, I'm using Chat Ollama and Human Message. So I do use those to get my application talking to a Ollama-based image model, and also to support multimodal prompts. So it's multimodal because I'm delivering an image as part of the prompt. I'm also using Langsmith traceable capabilities, so that's so I can trace the application when it's running using Langsmith. And to do that, I also use .env library to load in a .env file that contains information about where Langsmith has been hosted and what are the properties of the traces. Other libraries I'm using are the PIL library and the pillow-heif library, really just for image manipulation, mainly using it to convert heic files to JPEGs, and also make sure that I copy any metadata in the heic file over to the JPEG file. I'm using pydantic because when I request information about the images that I'm sending to my model, I want it to just come back with a list of 4 keywords that describe that image. To make sure it sends data back in the same way all the time, I use structured output option in Langchain, and to do that I need to use pydantic to define what that structured output class looks like. I use argparse to do all the command line argument parsing, so I set up the arguments that it's going to accept, whether they're required or they have default values, or whether they're optional. Also validate them a little bit, and also gives me some help about the application when you do a -- help from the command line. And the 2 main standard libraries I'm using is the OS library and the Shootle library, and I use that mainly for file manipulation, to walk the list of files and folders in the source directory, and to do things like copy the files and rename the files. While playing around with this, I was using open-webui just to try out different vision models and different photos. So first I'd do things like upload a photo, and then I'd ask questions about that photo. So let's run this. So this is Llama 3.2 vision. It's 11 billion parameter model, and that's running on my Mac. Okay, it didn't really follow my instructions about keywords, so let's try running that again. So that's more what I wanted, just a list of 4 words that I can use in like a file title, and gives me an idea what's in the photo. And let's just have a look at how performant it is. So 12 tokens per second is not super fast. Took about 7.5 seconds to generate that. So I wanted to see if there's other models that might do this better. So I'm going to try this out on the same image, same prompt, but this case I'm using a Granite vision model. It's kind of nice. It's 2 billion parameter model. It's a lot smaller than the Llama one, so let's try running that. And I've got it pointed at my development PC, which has the model running on a actual 2080 Ti GPU. So same problem, didn't give me the 4 keyword summary. Let's just try regenerating that again. Okay, it's having a go at it, but still not good at just giving me the structured text output. But we can have a look at the code to see how we can fix that. But the nice thing about this Granite model and running it on an NVIDIA GPU is it's analyzing the image a lot faster, so 70 tokens per second, and this one took about 2 seconds to analyze it. So well, I'm working on a large number of photos, so I might have a few hundred photos on my iPhone I want to upload. It'll be good to have it run a lot faster than what it's running on the Mac. So this is probably the model and the actual hosting environment for Ollama that I'm going to use. Okay, let's have a look at the code. I won't go into a whole lot of detail, but I'll show you the code and then we'll see it running in a sec. Not the prettiest code, but it's got all the pieces in there. So as I talked about before, these are the libraries I'm using to help put the code together. This is Python, and it's going to be using Langchain. Some of the things I'm doing here, so get a start time, just to be able to time the whole thing. Sometimes I want to print out statements, sometimes I don't, so I just use this little utility here. If the debug mode flag is set, then when I call debug print, it'll print out whatever I have in the call to it. If it's not set, then it doesn't print things out. So just a simple little debugger for when I'm tracing what's happening. So the first real statement is this register heic opener, so that initializes the converter that's going to convert my heic files over to JPEG files. This one here, so like I showed you in open-webui, if I just ask the model to tell me what's in the image and ask it to give me structured output, it doesn't always do that. The way you can force it to do that is in Langchain. You can tell it what structure you want the actual output to be, and the first stage of doing that is to define a class that defines the structure that you want it to output as. So I have this little class here called file keywords, and it's going to be made up of a list of keywords that are each string. So I'll show you when I invoke that later, but that's going to guarantee that the model's always going to give me the output in just a list of strings, or like an array of strings. Next thing I do is load this .env. We saw that in some previous videos, but basically I'm using Langsmith to debug as well. and the .env file has the Langsmith parameters, and you can look up Langsmith to find out more about how you do that. Another little utility I put together was this directory path, so it's just a little bit of code for validating that a string I passed as a directory path is really a valid directory path, and that's used in this argument parser. So I'm using the argparse module here to pass or set up command line arguments. So I'm just adding to this this parser. So first I put in some details about the program's name and description. So if I do a / help on the command line, then it'll spit out this information. And I also define the arguments that I'm going to pass to it. So I have a couple of required arguments, the source and destination files, and this is where I'm using this directory path function here to validate that directories are really being passed as the parameters. And then I've got a couple of optional parameters for model, which is the name of the Ollama model I'm using. I like this Granite 3.2 vision model. It's small and seems to be fast, so I've set that up as default, but I can swap in other models on the command line if I want. And the other thing I've done is pointed it at the environment for me that runs this model fastest locally. So it's the host that is using the NVIDIA 2080 Ti card. But I can also swap that out and point it at my Mac, or point it at even my Jetson Nano if I want to try some processing on that. So that's how I set up the arguments for this on the command line, and we'll see when I run it where I put in some of at least the required arguments. Next function I put together is to convert heic file to JPEG. So like I said, I don't want heic files being sent up to be stored. I prefer them to be JPEG. Other applications seems to have less hassle using those sort of files, so that's what I'm going to do. The other thing I'm going to do is check whether there's any image metadata on the file. So using this function here, exif data, it's going to pull any metadata into this structure here. Then I convert the heic file into red, green, blue definition, and then I save the file as a JPEG file with any image metadata if it found some. This function here is what I use to convert or create a file name based on a keyword list, and we'll see in a little while how I put the keyword list together by using Langchain and calling the image model. But having that keyword list and the file path, it pulls the file path apart, and then it puts together a new file name based on the original directory path that was in the file name, and then the keywords separated by underscores, and then the original file name on the end. So that's still maintained, so if I ever want to go back and find out what the original file name is, I have it there in the file name as well. So I join all those things together and then return the result. This is the main code. So we saw this in the flowchart where we process the files, or the source folder. So it drops through the source file, checks that the folder exists, and then it goes through and does what's called a walk of the files and the folders in that original folder or the root folder. So I'm using os.walk to do that. First time I'm just running through to look at find all the files under that root just to get a file count. That's all this part does. Sorry, file count total. And then I go through and then run through each folder first, and inside each folder I go through and first I'm going to go through and just see what heic files they are. So like I said in the flowchart, I don't want to write out MOV files that are related to an heic file. So this just builds up that list of heic files in the folder for use later on. Then we go through here, run through all the files in that folder, in the current folder. So remember, we're iterating through all the folders, but just doing it one folder at a time. Increment the file count to write some information about which file of the total files I'm working on. I also spit out the current time or the duration the program's been running, so I can see how fast it's going. And then I go through, and this is the conditions depending on the file type. So first, if it's an heic file, then I'm going to convert it to JPEG. So I'm using that utility I just showed you. And then I copy out the JPEG file I just created to the destination. Otherwise, if it's any of these type of image files, I just directly copy them. I don't have to do any conversion. If it's a move file, then I go through and check whether that file existed as, or that file name had an equivalent heic file name in my folder. If it didn't, so we've got a not here, then I'll copy the move file over as well. And then finally in here, for any of the extensions where it's an image, so it's going to be all the different extensions there for images. It's going to get the keywords, so this is where it calls Langchain. We'll have a look at that in a sec. To use AI to look at the image and get those 4 keywords, and then using the keywords to file name code I just showed you, it goes and creates a new file name. Then it renames the output file with that new file name. And this is the exciting bit for Langchain. So first thing, I surrounded this code by the traceable decorator. So that means whatever's going on in here is going to be sent out to Langsmith, so I can look at it later and see what happened down at the model level. So first thing I do is open up the output image, the image that I passed to it, encode that as base 64 encoding, because that's the format that the model will need. Then I create a human message, and this is where I describe the list of what I want the model to do with the image, and I pass the image in as well. So this is the definition for the image. This is the add-on that I haven't used before, is this surround the LLM with a structured output function. And this is where I pass that file keywords class I defined using pydantic at the beginning here. This one here. So this is where I tell it, hey, this is the structure that I want the output to be provided in. And by doing that, when I use structured LLM instead of just a LLM, it'll always return the result as in that data structure. And then I get a response from my model by calling structured LLM invoke with that message that I have up here. So the message has the prompt and the image in it. So I get a list of keywords. Sometimes it seems to duplicate keywords when it comes back, so I have this little bit of code here that gets rid of duplicates. And then I also go through just to make sure keywords can be used in a file name. I just clean them up a bit, get rid of any special characters, things like that, and return the clean unique list. So that becomes the list of keywords that I return. And remember, before up here we use the keywords and the file name to generate a new file name. And that's about it. So otherwise I just fire up the program, call the parser function to extract the arguments from the command line, set the source directory and the destination directory, and in here this is where I define or set up the LLM using chat Ollama module, and it's using the args model as the model name. So remember that is an optional parameter. It just fills in with that graphite image model otherwise. Sorry, granite image model otherwise. And base URL is the hosting environment for Ollama. So again, I've defaulted that, and it's an optional parameter. And then I call process files. So the most interesting part of this will be actually trying to run it. So let's try it out. Remember, I've copied in, got like 600 files that came off my iPad photo album. So let's open up the terminal. Now I'm going to run it with these parameters. So running the AI image caption Python script, that one up here. And the parameters I'm passing as the source directory is my temp image in folder. That's where I copied all those iPad images, and temp image out is where I'm going to send the output. Let's run that. I need to activate my environment, and let's try running it. First image will take a little bit of time to start interpreting, just because it has to fire up the model on my PC. But after that, it looks like it's taking 2 or 3 seconds to process each image, and there's sort of thing that it's putting into the file name. So that's the image we were just looking at. So that's looking good. Looks like I got 650 images to process, so I won't make you sit through that. So it finished. So for 648 files, took me about 28 minutes. And you see it still firing out decent file names for the images, much better than the original ones like image 9961. And then if we look at the files that created an image out, let's have a look in this directory. So we see all the files now have decent names on them. Even that original vintage photograph has the new file name on it. To make things easier to run in the future, I used pyinstaller to make a Windows exe, and then this shows you running the exe to do the same thing. Let it run through the same input directory, making the files. I just ran that all the way through just to make sure that the exe is working fine. And while it's running, I just brought up the GPU monitor in Windows. Gives you an idea of GPU use, the temperature of my GPU, and the amount of memory it's using. So as usual, I put everything out in GitHub. This is the AI Image Caption repository. Among other things, in the dist folder, here's the exe version of the application if you just want to run it under Windows. Otherwise, all the files are here. Got a little description down here of what it does as well.